Hello, my name is Jamar Sullivan, and my project name is Latent. Often when crowdsourcing for data to train a machine learning model, labelers are assigned a simple classification task. Crowdsourcing is a standard practice to get large amounts of data to train a model. And for many tasks, this is the extent to which humans are used. But what if there's a way to increase humans' roles in the machine learning process that would lead to more accurate machine learning algorithms without much added complexity? Attention is a concept made popular by papers like Attention is All You Need. It is the idea that there are specific parts of data that are more influential than others and should be emphasized by the model. For example, the presence of orange and black stripes might be a clear indication that the subject in the image is a tiger. Often, attention is represented as a weight vector, which has the same dimension as the original input. It changes the weight of different parts of the data point and is shown to increase the accuracy of algorithms that use it. But what does this have to do with increasing the role of humans? Machine learning algorithms that utilize attention learn important parts of data, but what an algorithm might determine is important may not be what a human might determine is important. Furthermore, it may take an excessive amount of labels for a machine learning algorithm to learn a good classifier. With the help of additional supervision signals, such as attention, algorithms can learn much faster. The potential difference between what the algorithms and humans think can lead us with the important question of whether or not human-provided attention can lead to a more accurate algorithm. The answer to this question could lead to more multidisciplinary uses of algorithms that utilize attention. To answer the question, we have to increase the role of humans during the classification task. We will have to ask people to give us more information alongside classifications, and we want to measure the impact of doing so. To determine the effects of humans' increased role in the labeling process, we need to create an interface to collect more information from users and then create an algorithm that utilizes their responses. This project's overall goal is to examine the role of humans in the training process and how much data we can get from them. We decided to use 750 randomly selected movie reviews from an IMDb movie review dataset. We have labelers determine if the review has a positive or negative sentiment, and then choose words in the review that help them determine that. We have an algorithm that can take a review document and attention vectors as input. Because we're asking for more than just label data from users, a custom interface must be created. The interface starts by explaining the task to the labeler. There are simple instructions that tell the labeler how to navigate the interface and what to do if they see an offensive review. The next page describes what might be considered a positive or negative sentiment for a document based on a traditional star review system. Next is the classification page. The labeler would then choose words that help them identify the document's sentiment in the next step. This process is repeated for 10 reviews that the labeler will examine. We modified a support vector machine classifier from scikit-learn that would take an encoded representation of a document. Documents are encoded using a bag of words representation, where the length of the input is the size of the entire vocabulary. Words are represented with 1 if it is present in the document, and 0 if it is not present in the document. To determine how much data we should collect in a real-world user study, we first ran simulated experiments based on attention simulated with a pre-trained machine learning model. Concretely, we simulated the attention for each document by training a deep neural network on the full dataset. We then used the simulated attention for each document to augment the training set for the SVM algorithm. Finally, based on the simulated model performance, we decided to collect annotations for just 750 reviews from the IMDb dataset. So what do we have to do next? The next obvious step is conducting the user study. We are crowdsourcing using Qualtrics, where we give users a link to the task and then a follow-up survey about their experience. We want to have the 750 reviews labeled by at least 3 people. Because of the size of the inputs to the SVM, a bag of words model can be inefficient. We are also looking into different neural network architectures like transformers. In conclusion, this project aims to expand the role of humans in the labeling process in hopes of producing more efficient algorithms with the same size dataset. We utilize feature feedback and attention from users collected from a custom interface to create a more accurate algorithm. We know that the use of attention is beneficial. Still, we have to continue the work on examining if human-provided data would be more useful than computer-generated and explore other implications of collecting data from users. Thank you.